Hello! In this video I'm going to be going over how to find whether an acid is strong or weak, and then also strong and weak bases. So going over strong acids, first of all, you could do one of two things. One, you could just memorize the 6 most common strong acids, those being HCl, HBr, HI, H2SO4, HNO3, and HClO4 are the 6 most common ones. If you don't want to memorize them, you could remember that if you take the number of oxygens minus the number of hydrogens, it's going to give you a number. If that number is 2 or more, it's strong. However, that only can occur if you have oxygens in your acid. But basically, if you have a binary acid, meaning it's just 2 types of elements like HCl, HBr, HI, in most cases it's going to be strong. So that would be chlorine, bromine, and iodine, when paired up with an H, are strong acids. Fluorine is the exception. You always have a rule in chemistry and then an exception to those rules. The reason fluorine and hydrogen, like HF, is not considered a strong acid is because it does not dissociate completely. The definition of a strong acid is an acid that will ionize 100%, meaning the H splits off from the anion, and you have these 2 ions in solution. And the reason fluorine is not going to dissociate with its hydrogens is because it's so electronegative. Remember from the periodicity unit, way back when, we talked about how fluorine was the most electronegative element, which means it has the strongest ability to draw electrons towards itself. So if it's drawing electrons, or for that matter other elements, towards itself, it's not going to want to give away that hydrogen, so it will not dissociate completely. Therefore it's not strong. Or you can just remember chlorine, bromine, iodine are the 3 halogens that form strong acids, along with sulfuric acid, nitric acid, and perchloric acid. So doing a little practice, why don't we look at perchloric acid? That is HClO4. We're going to do 4 oxygens minus 1 hydrogen equals 3. Is that number 2 or more? It is, therefore it is strong. Looking at this other one, why don't we do HNO3? We're going to do 3 oxygens minus 1 hydrogen equals 2. That number is 2 or higher, therefore it is strong. Looking at a weak acid, so looking at a weak one, why don't we do H2SO3? We have 3 oxygens minus 2 hydrogens equals 1. Is that less than 2? Yes, therefore it's weak. One more, H3PO4, 4 oxygens minus 3 hydrogens equals 1. That is also less than 2, therefore it is a weak acid. That is strong and weak acids. I now want to go over strong and weak bases. This one, in my opinion, is a little simpler because all you have to do is memorize this one trend, and then you've got it. You could memorize a few like NaOH, KOH, CSOH, CaOH2 are all strong bases, or you could think that if it's a cation that's in column 1 or in column 2 and it bonds with an OH, a hydroxide, it is a strong base. However, there are some exceptions. Magnesium is an exception, and also beryllium. The reason is they're smaller, and so they have a stronger attraction from that nucleus, and so it's not going to dissociate as easily as the other ones will dissociate. So it has to do with electronegativity, or in this case size. All the other ones in column 1 and 2 will form strong bases. So we just throw an example out there. Let's do NH4OH, ammonium hydroxide. Is ammonium in column 1 or 2? The answer is no, therefore it is weak. Next one, let's do KOH. Potassium, K, is found in column 1, therefore it's strong. one more example. Why don't we do cesium? Well, I don't need to put M brackets, but cesium hydroxide. Cesium's right here. It's in column 1. Therefore, it's strong. And that's pretty much how you determine whether it's a strong acid or base in a nutshell.